This is a continuation of a previous video in which our goal is to find all the critical points of a given function. To do so, first thing we do is we find the derivative and we set it to 0. Critical points are where the derivative is 0 or undefined. The easiest way to do this one is probably going to be with the quotient rule, although if you wanted to use a product rule, bring this up and use a product rule, I think that'd be fine. So we have the denominator, x squared plus 1, times the derivative of the numerator, which is 1, minus the numerator x times the derivative of the denominator, which is 2x. All over x squared plus 1 squared, the denominator squared. Simplify as much as possible to see if we get something easy to work with. On top, we have x squared plus 1 minus 2x squared. That will be able to simplify the denominator. There's not much we can do. The numerator, though, we can see is going to become a 1, let's write it this way, 1 minus x squared, as this term and this term will combine, over x squared plus 1 squared. Now, because we have a rational function for the derivative, we're going to want to set both the numerator and the denominator to 0 to see, because, again, critical points can be where the function is 0 or where the function is undefined. So 1 minus x squared equals 0, and we'll take the denominator, x squared plus 1, the quantity squared, equals 0. What we're going to find is this is not going to be a solvable equation. So there's no place where this function is undefined, so that's not going to add to any of our critical points. This one, however, will. We have 1 equals x squared. We'll square root both sides, and we do have 2 critical points because we have to account for the positive and negative. So there's the 2 critical points for that function. One more example of finding critical points. So if f of x is 2x squared, e to the 5x plus 1. So f prime of x, well, this part's going to be a product rule. This part's easy. The derivative of 1 is 0. Here's where all our work's going to be. So maybe I hold this part constant, so 2x squared times the derivative of e to the 5x is e to the 5x times 5, because it's a chain rule. Plus, now I'm holding this part constant, e to the 5x times the derivative of 2x squared, which is 4x, and there's my derivative. Now, to make things easier to deal with, I'm going to factor as much as possible. So if I look for common terms, I've got a 2 here and a factor of 2 here. So I'm going to pull a 2 out of both. I can pull 1x out of both. And I can pull an e to the 5x out of both. So let's see what that leaves. We pulled the 2 out, we pulled the 5x out, and we pulled one of the x's out. So that leaves us with a 5x here. Over here we pulled the e to the 5x out, we pulled a 2 out, and we pulled an x out. So plus 2. We're going to set this equal to 0, and that means we can set each part of the product equal to 0. So we have 2x equals 0, e to the 5x equals 0, and 5x plus 2 equals 0. This has no solution. It will never be 0. This has a simple solution that is 0. And this one, if we solve, we're going to get x equals negative 2/5. So there's our 2 critical points.